Introduction to deployment. Deployment ensures that your smart contracts are accessible and functional on the blockchain. This process involves preparing your contracts, deploying them onto a network, and verifying their integrity. A smooth deployment minimizes risks and ensures your DApp works as intended, preventing costly errors and vulnerabilities. Our pre deployment checklist includes code review and audit, comprehensive testing, optimizing smart contracts, and preparing deployment scripts. Code review and audit. Before deploying, conduct a comprehensive code review and security audit to ensure your contracts are secure and function correctly. Engage third party auditors and use tools like Mythex to detect vulnerabilities such as reentrancy attacks, where an attacker repeatedly calls a contract to drain funds. Another common issue is integer overflows, where arithmetic operations exceed the maximum value, leading to unexpected behavior. Unchecked external calls can also expose contracts to risk if the called contract is malicious. For example, a withdraw function that allows users to withdraw funds without first updating the contract's balance is vulnerable to reentrancy attacks. Comprehensive testing. Testing is vital to ensure that smart contracts are reliable and behave as expected. Perform unit tests on individual functions, integration tests to ensure different parts of your code work together, and end to end tests to simulate real world scenarios. Use tools like Hardhat for writing tests in JavaScript, where you can simulate scenarios using ethers.js. Mocha and Chai are excellent for creating test suites. For example, in Hardhat, you can write a test to verify that a token contract correctly assigns the total supply to the owner upon deployment, ensuring it meets the intended specifications. Optimizing smart contracts. Gas optimization is crucial for reducing transaction costs, making your dApp more efficient. Minimize storage usage, use efficient data structures, and optimize loops. SafeMath is a library that helps prevent integer overflow and underflow errors, which can otherwise lead to significant vulnerabilities. For example, a function that directly manipulates balances and minimizes storage access can greatly reduce gas consumption, making transactions more affordable. Preparing deployment scripts. Deployment scripts automate the process, ensuring consistency and reducing human error. Hardhat and Truffle offer frameworks to write scripts that compile and deploy contracts to specific networks. Automating these tasks ensure accurate and efficient deployment. For example, a Hardhat deployment script can automate the deployment of a token contract, logging the deployed contract's address and ensuring the process is error-free. Now, deploying to a testnet. Deploying to a testnet like Rinkebai allows for thorough testing in a safe environment before going live to the mainnet. Testnets use test-eth, enabling you to identify and fix issues without risking real funds. Configure your hard hat project with a Rinke by ensuring your dApp functions correctly before mainnet deployment. The configuration involves setting up the Rinkebai network in your project and deploying the contracts to this test network. Verifying contracts. Verifying your smart contracts on platforms like Etherscan is essential for transparency. This process allows anyone to inspect the code, ensuring it matches the deployed version and contains no hidden vulnerabilities. Hardhat can automate this process, simplifying the interaction with Etherscan's API. For example, a verification script in Hardhat requires the contract's address, constructor arguments, and compilation artifacts. Once executed, it verifies the contract on Etherscan, making it publicly accessible and transparent. Post deployment monitoring. Monitoring your contracts after deployment is crucial to maintain stability. Tools like Etherscan, Dune Analytics, and the Graph allow you to track transactions, analyze on chain data, and create custom dashboards. These tools help you monitor your contract's performances and detect any issues early. For example, the Graph enables you to create a subgraph that indexes data from your contracts, allowing you to monitor events like token transfers and analyze the contract's activity. Handling post deployment issues. Even after deployment, unexpected issues like bugs or performance problems can arise. Open Zeppelin Upgrades is a library that allows you to upgrade contracts while preserving state and functionality, ensuring a smooth transition for users without disrupting the contract's operation. For example, upgrading a contract using OpenZeppelin involves retrieving the upgraded contract's factory and interacting with the proxy contract to apply the upgrade, ensuring continuity in contract operations. Best practices for deployment includes rigorous testing, thorough code reviews, and the use of automated deployment scripts are essential. Deploy to testnets to catch issues before mainnet deployment, verify contracts for transparency, and use monitoring tools to track performance and address problems early. To summarize, this session covered the crucial steps in deploying and managing smart contracts, including pre deployment audits, testing, optimization, and post deployment monitoring. By following these practices, you can ensure a smooth and successful deployment process, safeguarding your dApps, functionality, and security. For any further doubts and queries, please reach out to us on our Discord server. Thank you.